And very good day for everyone who want to watch my presentation. So I will start the presentation. So my name is Ahmad Shahi, and I will present the data and structure algorithm project. This is the title: e-commerce product recommendation system. The description for this title will is designed to provide personalized product recommendation to users based on their business browser history, preference, and behavior on an e-commerce platform. The system aims to enhance user experience, increase user engagement, and drive sales by suggesting relevant product in that align with the user's request. How this kind of application, e-commerce application works? It uses user authentication. It allows user to log in or register on the platform. Queue can be used to manage the order of authentication requests. Browser history analysis. It analyzes the user browsing history to understand their interests. The linked list can efficiently store and manage a user's browsing history. Product retrieval. It retrieves product data for the database. Hash map can be used to store product data, which is product mapped to its unique identifier. For example, product ID. So let's see, recommendation generation. It will use the recommendation for users algorithm to generate personalized product recommendation. We can use trees such as binary system or balanced trees. We can use to organize and manage product data for efficient recommendation generation. So how do we describe the data organization? Firstly, we handle user requests in the recommendation system. User requests for recommendation could be managed using queue. We will using queue for for my project. When a user logs in or visit the site, their request for recommendation can be added to the queue. Secondly, sequential processing of recommendation. The system will recommend the best interest for the user once the user is get into the system. So we generated and served to users in order to request them, similar to the first in, first out nature of the queue, FIFO. And lastly, the dynamic queue size. The size of the queue can vary based on user requests on the system. During busy periods, the queue will expand to accommodate more requests. So we will be sure ensuring that no user request is lost or delayed. So we will explain more about queue data structure operation. This is a NQ operation. When the user logs or visits the site, their request for the recommendation is added to the end of queue. We just like the basic operation of NQ, which is we insert an element from the front of the queue with an element of the tail of the queue. This is the image below for the NQ operation. So we review the queue. When the system is ready to process a user request, it queues the request from the front of the queue and generates recommendation for the users. So we the same as the basic procedure of the queue, which is to remove the element of the head of the queue. So the image shows the operation of the DQ. We also we pick operation is similar to the queue operation. It just not remove the element from the stack, from the pick, from the queue system. Sorry. So before serving a user request, the system may want to pick up the next request in line without the queuing. So we need not remove the head or tail of the element. So it may show the operation of pick. So we also can use can check whether the queue is empty or full. This is the image of empty and full queue. So we can review more in this code. From this code, we can check if the queue is empty or full. Then we can check also if the queue is empty and we're using is empty method and show in the code. If the queue is empty, it prints queue is empty. Otherwise, it prints it gives false statement queue is not empty. We can also check if the queue is full by checking the comparing the max size of the queue. If the size of the maximum to the maximum capacity, it will print the queue is full, and otherwise it will print queue is not full. So we will present the algorithm from another code. This is the another code. From that code, we will use the loop from one loop from the code. So we do the analysis first. The algorithm iterates through the authentication queue and process each user authentication request one by one. The time complexity of the poll, the important poll element we use to operate the queue, we implemented with linked list is O1, which is the constant. Also, we assume there are end user authentication requests in the queue, so the whole operation will be linear running time same to ON. So this is full step how I can get the answer. So the steps show the calculation of algorithm efficiency. Since its poll operation takes constant time in it execute once. Execute once, it means when one the loop is handled by one user, which is same as n. The poll we assume it as constant. So from the operation, the function operation, we will use n minus 1. So the final answer, we will get 0n, which is linear runtime. The time complexity algorithm is linear. So the step to estimate efficiency for the whole operation, the primary operation is algorithm is a poll, which is stated at the previous pool, a loop to retrieve and remove element from the queue. We also can estimate by count each of the iteration of the loop. So the iteration of the loop is only once in the loop. And also we can analyze time complexity. So this is iteration involve a constant line operation or one for the poll one. The overall time complexity is new, where n is the number of user authentication requests in the queue. So we can conclude from this operation the algorithm. So we can processing authentication request using a queue has a linear time operation where n is the number of requests in the queue. The algorithm also provides efficient processing of the authentication requests, ensuring fairness in handling all the authentication requests. So So I identify the four important element for the operation queue. This is collection class, interface use, operation for the queue interface, and operation for linked list class. So the collection class, we will use queue. The queue interface is used as a collection class for managing users' authentication requests. In the code, linked list, we use linked list as implementation to queue interface. So if interface use, the queue is interface is used to define the contract for the queue data structure. It also provides method like offer to add elements of the queue and poll elements to retrieve and remove elements for the queue. Although not iterable, although which is not explicitly stated in the code snippet, the interface is implemented by queue, so it allows for the iteration over the elements in the queue using for each loop or iterator. So the operation of the queue interface, we have three, which is offer, poll, and pick. Offer will add the specified element to end the queue. Poll, it will retrieve and remove head of the queue. Also pick, it retrieve but also not remove the head of the queue or just null if the queue is empty, as I stated more detail in the previous slides. So lastly, the operation for the linked list class. Offer, we add the specified element in the end of the list, and also poll, we will remove the first element of the list, same as the previous slide. So the conclusion and summary for my presentation, the e-commerce product recommendation can leverage user data and product information to provide personalized recommendation. We also use efficient data structure algorithm to make the system performance more stable and more scalability. We also collaborative algorithm are commonly used for recommendation generation, which is offering efficient and effective personalized recommendation. And lastly, we, we can handle the continuous optimization and refinement, also necessary to improve the system accuracy and responsiveness. So that's all for my presentation today. Thank you for the attention.